So hello everyone, and welcome to Energy Management Best Practices and Latest Tech. My name is Behdad Bahrami. I'm the CEO and founder of Edgecom Energy. And at Edgecom Energy, what we do is we supply IoT energy metering solutions combined with artificial intelligence solutions that help large industrial manufacturers navigate how they consume energy, basically leads to them saving a lot of money and reducing their emissions. So I'm really excited to talk about energy management best practices and latest technology with you today. And I want to thank you all for being a part of this presentation. So what made me start Edgecom Energy? I was an industrial energy manager here in Ontario, Canada. So what we have is a position called energy manager. And what it means is somebody who is placed by the local utility inside a large manufacturing company to help them navigate this world of energy. So rate tariffs are complicated, bills are complicated. There's a lot of different opportunities for savings. There's a lot of different opportunities for upgrades inside these facilities. And what the utilities in Ontario found about 15, 16 years ago, they came to the conclusion that it's actually cheaper to help people invest in energy efficiency than it is to invest in more plants and more power production, right? So when they started this energy manager program, they found people who had an understanding of how facilities operate, people who had an understanding of how energy works, and they placed us basically like double agents inside these industrial facilities. So when I was in that facility, it was a very large plastics manufacturing facility, an extrusion facility. I was able to find $2 million per year of savings within the first year of working there. And that just shows the potential that exists in energy efficiency. And by having the right data, having the right technology, having the right understanding of how to manage energy, the dollar savings that can be achieved are huge. And secondary to that is the emissions, right? So we don't need to produce more energy than required. So why not run these plants more efficiently? That way you're saving money and you're reducing emissions. So when I was in that position, luckily I was able to save that company a lot of money. But the issue that came up is that acquiring the data, gathering the data, and doing all the things that I had to do were not as easy as they could have been, right? At the same time, I had friends who were going and working at Google. I had friends going and working at big tech companies like Shopify, and data was the rage back then, right? And it's still a huge part of how industry is evolving. And energy wasn't caught up to what the rest of the industry was doing, right? So even though in finance, even though in retail, even though in a lot of different sectors, data and AI were starting to take shape back in 2011, 2012, energy was very behind. So that was the reason why I started Edgecom Energy. The goal was to bring energy management into the 21st century and combine data, AI, and all the different tools to make managing these programs and getting cost savings much easier for most industrial customers. So the clean energy revolution is here. We know it's something that, it's been talked about for a couple of decades now, but really now with the advent of electric vehicles, with wind power, solar power, it's finally at a point where it's economically competitive with traditional fossil fuel production. Now, we're still going to need fossil fuels, obviously, for a lot of different sectors. I come from a plastics background. I'm a materials and polymer engineer, so I know better than anyone that there's no replacement for oil for specific parts of the industry. But when it comes to energy and when it comes to transportation, when it comes to industrial manufacturing, the clean energy revolution is already here. And the reason for this is that it's cost competitive now with a lot of other forms of energy. There's still some caveats there. There's still some things that we have to navigate. The wind isn't always blowing and the sun isn't always shining. So battery energy storage system is coming in to fill in those gaps. Nuclear is filling in some of those gaps. But overall, the trend is clear now. And this is a one-way trend, right? So I don't think we're ever going to go back to, being predominantly fossil fuel powered. And we know that the clean energy revolution is going to be huge for the economy, and it's going to be huge for how energy is consumed. Now, at the same time that the clean energy revolution is happening, a lot of different changes are happening on the energy grids as well. So whereas in the past, we primarily had centralized power production, right? So big power plants, coal plants, gas plants, really big centralized power production facilities. And we had supply side management of energy. So basically, supply side just meant if people are consuming more, they're turning on their air conditioners, their factories are running at full blast. The utilities basically had one option, and that was to just ramp up how much energy they produced, right? So managing the supply as opposed to managing the demand side of energy. And then these power plants, again, were centralized. That paradigm is starting to change. And in a lot of jurisdictions, Ontario, for example, California, these have already started to change. And we know that decentralized is the future. So what this means is that every home is going to be producing not maybe all of its power, but it's going to be producing some of its power, right? So every home, every business is going to be producing some sort of power, either through solar panels or through wind or through other technologies that may come up, right? So it's decentralized now. At the same time, whereas in the past, people just consumed energy in their businesses and in their homes, that's no longer the case, right? So now we have prosumers and smart consumers that are investing in Nest thermostats, that are investing in battery systems for their homes, that have electric vehicles in their homes. So every piece that's connected to the grid that used to just be an endpoint that consumed energy can now actually inject energy back into the grid as well. So all of this is combining to create some opportunities and create some changes. And the overall scheme here, they call it the energy transition. So we're transitioning from a predominantly fossil fuel centralized energy paradigm to a new energy paradigm where it's decentralized and primarily based on renewable energy. And what this creates is opportunities for smart management for a lot of different facilities and a lot of different programs. Now, utilities are trying to figure out how this is going to work. System operators and grid operators and transmission operators are trying to figure out how this is all going to work. So it's very much in flux right now. None of it has been figured out completely, but different aspects of it are starting to take shape and come together. The analogy that I like to use for the energy transition is telecom in the 90s, right? So when AT&T and Verizon and these companies were putting up cell phone towers back in the early 90s, there was no clear case of where this is all going to go, right? So they were just setting up the infrastructure, and then it took some time until the iPhone came out and Android came out where they could really take full advantage of those pipes that had been laid. And right now, it's like the mid 90s for telecom was right now in the energy sector, right? So we're really early in the process, but understanding where this is going to go and understanding what the potential is here will have true ramifications for any sort of energy intense business. And it's going to lead to a lot of opportunities for savings that, if you're not ahead of the curve, you're going to miss these opportunities, right? And the earlier you get into these programs, usually the more advantageous that they are. So at the same time that energy is undergoing a transition, industry as a whole is undergoing a transition as well. So where we had Industry 1.0 back in 1784, that's a very specific date that my team put together, but it was probably closer to the early 1800s where steam power really started becoming a mainstay in how production occurs, right? Before that, we had, animals were basically the source of power, right? In the early 1800s, mechanization and steam power really started taking shape. That led to people aggregating in cities, mass production, assembly lines, and division of labor, right? So having specific personnel doing very specific tasks. And that was Industry 2.0 that really started in 1870 and took us throughout the early 1900s until Industry 3.0. So Industry 3.0, in the early 70s, 80s, automation, control systems, computers, and electronics really started taking over how we produce things and how we manufacture goods. And then now we're at a point where automation and computers are there, but cyber physical systems, so the connection of the physical and the digital, putting sensors on everything, right? Everything being measured, everything being monitored. And that is Industry 4.0, right? So really in Industry 4.0, the difference is that, yes, we have the automation, we have the computers, we have the electronics. Now we have everything connected to the internet. We have virtual versions of everything. So digital twins, where imagine you have an industrial facility running and basically producing something, well, you have a digital version of that created inside a computer running somewhere where now you can test different hypotheses and test different products and figure out what kind of results that will actually have on the outcome, right? So everything being connected, everything being digital, everything being basically connected and combined and managed very, very granularly down to specific pieces of equipment, right? So that's what Industry 4.0 means. And this is going to create a lot of opportunities, but it's also going to create a lot of changes in how things run. Through Industry 4.0, automation will also continue to become a bigger part of how things are produced, and understanding every single aspect of an industrial process is going to become the norm, and it's going to be streamlined down to even smaller industries, right? So if you think about, a large oil refinery, well, they have most of their things measured and analyzed, right? But if you go to a furniture shop, maybe they don't, right? But what we're finding is that even that furniture shop now is starting to catch up and starting to measure and monitor every single aspect of their production, and really, take advantage of that and find the efficiencies that will create. So there's an energy transition happening. At the same time, there's an industrial revolution that's happening. Now, I mentioned the energy transition, and there's a lot of different things that a facility can do to navigate this energy transition. And there's a lot of different opportunities that arise as different utilities and different system operators and transmission operators get into these programs. The potential becomes bigger and bigger. The starting point is really understanding where you are, understanding what the potential is in your jurisdiction, and then starting to navigate that effectively, right? So where do we start? We start with a bill analysis, right? So most industrial facilities, what ends up happening is they consume energy and then they pay a bill, right? That's it. That's the extent of energy management. But understanding that bill, right? So diving deep into it and understanding where each of those line items comes from and what you could actually do inside your facility to affect those line items is very important, and it could be very, very cost effective, right? So doing a bill analysis is very important. The next part is a load inventory, right? So having a deep understanding of which parts of your plant are consuming the largest volumes of energy and at what times, right? So it's not just about energy as a whole, it's also about demand, right? So at what times are these machines operating? At what hour of the day are most of my lines operating? And having a really deep understanding of that load inventory, stacking up all the different savings that could be achieved and stacking up all the different pieces of machinery in your plant. You have boilers, you have chillers, you have all these different things, stacking them up and understanding when is that peak happening and what does that load inventory look like. The next part is tariff optimization, right? So do you understand, again, based on the bills, what are the different drivers of expenses on your bill, right? Are you on the right structure for the way that you consume energy? When you look at your load profile, when you look at how much energy you're consuming when in your facility, is it aligned with a bill that actually makes sense for you, a rate structure that actually makes sense for you? Are you looking at retrofits, right? So that's the next one. So have you looked at upgrading your lighting to LED? Have you looked at upgrading your boilers and chillers? And how are you prioritizing when to upgrade each piece of equipment? And have you looked at what the ROI looks like by doing that upgrade earlier as opposed to delaying it, right? So we know that in most facilities, what you're trying to do is you're trying to maximize ROI and maximize production throughput. But in many cases, the ROI and the actual profit increase that you get from undergoing an energy retrofit earlier is actually much higher than increasing production, right? And that's just because any savings you have in energy is directly affected on the bottom line and directly affects your profits, whereas more production also has more costs, right? So you need to look into those numbers and really understand what energy means for you. There's also a potential for power conditioning. So in a lot of different jurisdictions, there is actually a penalty if your power factor on your bill is low. And that just means that you're affecting the grid negatively. The way that your machinery operates affects the overall the distribution grid in your area. So you might actually be affecting your neighbors negatively. So understanding those power factors and taking advantage of that. And then finally, generating energy on site, right? So you want to go through and optimize what you currently do, and then eventually create some energy on site as well through solar panels or wind, if that's possible in your area. So what Edgecom Energy does, and I touched on this a little bit earlier, we empower large energy consumers to take control of their energy costs and reduce emissions by harnessing the power of IoT and AI, right? So we provide meters that allow you to understand that load inventory, that allow you to understand what each piece of machinery in your factory does. And then we use AI to analyze these bills, analyze these tariffs, and make recommendations for things that will save you money and contribute to better sustainability outcomes. So all of these things combined go into one software platform. Our mission has always been to empower large energy consumers to reduce energy costs. And we know that energy costs are a huge issue for a lot of large production facilities. And we really believe that North America is where a lot of innovation can happen and is where a lot of production should be happening, right? It's better for the planet. It's better for our economy. Why are we producing everything offshore, right? So energy is a big part of that. If we're able to help industry produce things with lower energy costs, then more of that production is going to come back to North America, and that's going to lead to better outcomes for everyone. So that's a big reason why I do what I do. And the vision for us is to be the transformational change agent, improving how humanity consumes energy. So the way we achieve these things and the way that we're able to actually help is using an ecosystem, right? And I think this goes to, it doesn't have to be our platform, it doesn't have to be our solution, but I think understanding that you need an ecosystem of partners, of tools, of solutions that help you navigate this energy transition. You can't do it on your own, so you need help, right? And this is just an example of the kinds of help that an energy management information system like Edgecom Energies could provide, right? So you need peak management, right? So the first program that most utilities are starting to roll out is demand response or peak management programs. These peak management programs have really quick ROIs. And by just changing when you're consuming energy in your facility, in most cases, you're able to save something on the order of 20 to 50% on your total energy consumption. So understanding these programs is really important, and understanding how you get charged for them is really important. So peak management is one thing you need to look at. Demand response and peak management, these two go hand in hand. There's also an opportunity for battery energy storage systems to manage those peaks. So more and more grids across North America are bringing the opportunity to install battery systems inside your plant. And that battery system, not only does it give you more reliable power, but it also actually creates a new revenue stream for you. And then finally, what we have is our IoT platform. So the IoT basically is sensors that get installed on each piece of equipment inside your facility. And that way, you know, real time, you look at your phone and you know, what is my boiler doing? What is my chiller doing? What's each line doing? What's the throughput? And that makes your life a lot easier. And eventually what we're doing is we're bringing all this data into an energy co-pilot. So instead of you having to analyze and instead of an expert having to analyze this data and make sense of it, there's actually an AI that you can talk to and ask questions, and it will actually make recommendations for you. And I'll give you a couple of examples on that in the next coming slides. So this is our new AI energy co-pilot, and this is again where the industry is headed. So this is just an example of a solution. There are multiple solutions out there, but I think at the end where we're going to get to with energy management is that every facility will need to be monitored and measured and analyzed effectively. And every facility will have to understand their rate structures and their bills. And the only way that every facility can have that in a cost-effective way is through AI, right? So you could ask it questions like, what happens if I change my production shift? Instead of starting at 6 a.m., they start at 8 a.m. How much money would that save in electricity costs? How much emissions would that reduce, right? You could ask it questions like, you know, why was I consuming more energy on Monday versus Wednesday this week? Or you could ask it questions like, can you compare line 1 with line 2? Or can you compare this plant with that plant and give me some analytics as to why this plant is so much more efficient than this plant, right? So the AI is able to pull the data from those IoT sensors and really give you insights and answers as to why these things are happening. And again, this is the way the industry is headed. Eventually, this AI will also be able to control some aspects of your plant, right? So if you allow it, it will be able to actually optimize the set points of your chiller or optimize the set points of HVAC or other pieces of equipment. So all of that is going to make your plant run much more efficiently, much easier answers, much easier solutions, and much better asset performance. And actionable recommendations are the key here. So the way that we do that is using the IoT platform. So the IoT platform is able to basically give you consumption on water, gas, vibration, and power. And all of that gets fed into the AI to be able to give better results and solutions. Peak management is a huge part of these programs as well. So understanding how to navigate these peak management programs is very, very crucial, and it's very lucrative, right? So understanding how you can actually mitigate peaks and what the cost savings that arise from that are huge. And more jurisdictions are bringing in these peak management programs. And that's something that we can help out with. And those peak management programs go hand in hand with demand response opportunities. So basically, when the grid is undergoing stress, instead of, again, turning on a large power plant, what they can do is they can go to multiple industrial facilities and ask them to reduce a little bit. And in response to that, you get paid money. So here in Ontario, we're having very good results with these programs, and they're increasing the reliability of the grid and making sure that we don't have any sort of power outages. So these kinds of programs are going to become much more common, and they're going to become much more lucrative throughout the years as we undergo this energy transition. Finally, NeuroCharge allows us to dispatch battery systems. So as I mentioned, battery systems allow you to have better reliability in your facility, but they also allow you to mitigate those peaks very effectively based on prices of energy. And you need someone to be able to monitor and dispatch those batteries for you. And that's what that NeuroCharge does. So our team, this is, we have a bunch of PhDs and a bunch of engineers working here. And I just want to give you a couple of examples of how these kinds of solutions save large industry money, right? So I think this is the key thing here. Everyone's looking at cost savings, and I want to talk about how this actually works. So one of our clients is a company called Bach, right? So they're a German injection molding company. And what they do is they actually make the base of office chairs, right? So most of these ergonomic office chairs that you see, the common office chair, they make the base of it, right? And the backing, right? So they do that through injection molding. So German company, they have about 8 facilities worldwide, and they've been a customer of ours for about 5 years now. And over time, they started getting more and more of our solutions. And about a year ago, they decided to install these IoT sensors. So we shipped them a box, including 48 devices. Their electrician, their on-site electrician, was able to clip these devices. The devices are battery powered and wireless. They were able to install these on all their lines and all their main auxiliary machines. So their chiller, their boiler, their HVAC, their production lines. In one afternoon, they were able to basically monitor and measure energy within the whole plant. Now, that data allowed them to see that during peak events, right? So during the times where electricity prices peak significantly, certain machines are being left on that didn't need to be, right? So when you look at those machines, you can't tell, but the heaters on those machines were actually left on, right? So when you look at the panel on the dashboard, you were able to see that energy consumption is much higher than you would think. And that right off the bat led to them saving $98,000 a year by making sure that those things are turned off at the right time. So this goes to show how important monitoring can be for a large industrial facility. So that's one example is Bach. Another example is a company called Celestica. So they make chips that are used in a variety of different applications. And what they found is they were targeting 5% energy savings within their plant, and they weren't measuring specific pieces of equipment. So by installing monitors and meters on every single line that they had, they were able to, over time, compare multiple lines and see that things are being left on between shift changes, things are being left on overnight. And again, when you just look at these devices, you can't tell that they're consuming energy. But once you have that meter installed, alarms come up and the dashboard clearly shows you that there's wasted energy here. And through that initiative, they were able to save 5% in corporate energy. And it also allowed them to increase production uptime because they were able to find pieces of equipment that were about to fail because they had different types of, they have a different energy pattern when they're about to fail. And that actually increased their production uptime by 7% as well. So Edgecom Energy, we're working with some of North America's largest companies, Fiat Chrysler, Stellantis, Johnson Controls. We're working with the Royal Bank of Canada. We're working with Metrolinx, which runs all the train network here in Ontario. And our goal, again, is to help you save energy and run your operations more effectively and more efficiently. So if you have any questions, please reach out to myself or someone from my team, and we'll be more than happy to help you navigate this energy transition. We know that it's going to be a big change for industry, but understanding the programs and being ahead of the curve is going to really give you that competitive advantage. And we're here to help. So if you have any questions, please reach out to myself. And if you have any questions regarding the energy transition, how to navigate these rates, how to analyze bills, if you need help talking to your utility, we're here for you, and we're more than happy to help. So I want to thank you for your time, and thanks for having me as a part of the SCDC session today. Take care.